Hey guys, I just wanted to make this video for the practice final for Signals and Systems. Well, this is the end of the semester, right? This is very exciting, and I think this final will be pretty good, honestly. Looking at all the questions, I won't say this is the easiest test, but it's definitely not the hardest. And actually, a lot of the problems on here is mostly just math, doing algebra and stuff on the calculator, which is really good. The circuit problems are a little bit harder to do, but if you just know the tricks on how to do it, it's really not too bad. So I want to make this video, and I'm going to be jumping around between the questions. I will not be doing them in order. I'm going to save the circuit problems for last. But oh, hold on a second. I forgot to connect this. All right. And there we go. Now I could use my mouse or my tablet. So let's get started. So for problem number 1, I have to copy the question here. Hold on. Here it is. Okay. For problem number 1, it is saying find the inverse Laplace transform of xs. Okay, so let me copy this over. Yeah, honestly, these problems are not too bad, especially doing this because this is just partial fractions, which we learn in like, what is it, Calc 2, Calc 3. So this isn't too bad. It's just using a different method to find the partial fractions. So for xs, we're given this equation, and we have to separate this. So we're going to find k1 over s plus k2 over s plus 6 plus. Now just remember, over here this is an s plus 4 squared, and when it's squared, you always want to make sure to do s plus 4. Then also do k4, which is s plus 4 squared, right? Because if you have just one, then it's just going to be one constant. But if you have something an s plus a number that's being raised to some exponent, you want to make sure you do as many constants as that exponent says. So if this was like 3, then there would be 3 constants here, k3, k4, and k5. But there's only, this is only being squared, so there's only going to be 2 constants that we have to find. So to do this, we're going to be using the Heaviside method. So let's do this. K1 is equal to do the Heaviside method, basically you're just going to multiply the top and bottom by this first part over here, and we're going to do it for each and every part. So I'm going to write this one time, but I won't write it for the other times. So this is s times 9 times negative s squared. As you can see, both Professor Ozturk and I are going to take out the 9 just because it's easier to solve. And this is s plus 6, and s plus 4 squared. And so we're going to take out this s, right? So it's only going to be s plus 6 and s plus 4 squared. And for the next ones, I'm just going to not include that. So if for the next one, when I multiply it by s plus 6, I'm just not going to include the s plus 6. Let me just make sure that I'm recording. Yep, okay. And so we want to put in a constant for s where this would be treated as 0. So if there's just an s over here, all you have to do is 0. If you were to have this equation, right, and you keep the s in, and it's times the s plus 6 times s plus 4, squared, right? If you put it in a 0 here, it multiplies this whole equation by 0. So at the bottom, it's just going to be 0. And that's what you want to do for each and every equation. So let's take this out. All right. So this is going to be s is equal to 0. So basically, if you plug in 0 to all of these points, this is very simple. This is going to be 9 times 2, which is 18. And what this is going to be 4 squared, which is 16 times 6, which is 96. And then you could simplify that to 3 over 16. So see, at first, this is very simple. It only gets a little bit complicated when you get to this s plus 4 and s plus 4 squared. So, well, let's first do the K2 before we talk about that. So as I said, we're now going to be multiplying s plus 6 by the top and bottom, so I'm just not going to include that. 9 negative s squared is going to cancel out anyway, so plus 2. And I'm just going to write s times s plus 4 squared. Now, to make this, the s plus 6 is 0, you would make this negative 6. You would make s negative 6. That way, negative 6 plus 6 turns into 0, and then it multiplies by this whole thing, and the bottom part will be 0. So this is going to be s is equal to negative 6, right? Another thing you could do is just, so this is s plus 6, right? Which is equal to 0. S is equal to negative 6. That's another way, right? Getting back to high school. Delete that. Okay. And just by doing some math, plugging in negative 6 to all parts, which could be done on the calculator, this is going to be negative 360 over negative 24. And that's going to be equal to 15, because the negatives cancel out. Okay. Now we're going to talk about the s plus 4 and the s plus 4 squared. Since we're using the Heaviside method, it uses a specific rule. I'm not going to bore you with the details because it is a very extensive rule. I could even look it up for you guys right over here. Just to show you. That's not it. Where is it? This one. So if I just look up Heaviside method, let's see if it shows Heaviside method with squares, maybe. With squares. Honestly, it's not too important. It's just this like really, really big equation. And you don't really have to know this big equation, so might as well not show you. I'll just give you the simplified version. So let's say we have s plus 4 squared. We're going to find out what goes on the outside of the equation. So what I mean by that, I'll just show you right here. So we're going to do 1 over the exponent. So the exponent is 2 minus 1 factorial. And this is going to be d2 minus 1 over ds 2 minus 1, right? And if we were to solve this out, 2 minus 1 is 1, and 1 factorial is 1. So this just turns into 1. D2 minus 2 minus 1 is 1, and 2 minus 1 is also 1. So this is just going to be d over ds, right? If you're only doing squares, then it's just going to be one derivative. Now, if you're doing something like a higher order one, s plus 4 cubed, the equation will look a little bit different. So it would be 1 over 3 minus 1 factorial, d3 minus 1, ds3 minus 1. And this will turn into 1 half d2 over ds2, which just means that, well, this is just a constant 1 half, but this over here, it means that you're going to be taking two derivatives. Now, most likely, he's not going to do that on the final. If you had to take two derivatives, that would be really long. It would be a really, really long problem. And I think that might like occur next semester. This does come up again. So just make sure to remember this for next semester. But most likely, you're not going to have to do more than just one derivative for the final. And even if you did, you know this equation right over here, 1 half d2 over ds to the second. But definitely, there's not going to be three derivatives. Three derivatives would be way too much. So, getting back to the problem, you might be asking, okay, well, where do we put the DDS? It goes out in the front. That's pretty much it. K3, to find K3, you're going to put the DS out in the front. Yeah, you could honestly just memorize this so you don't have to know this, formula up here. If it's being squared, then you only take one derivative. If it's being cubed, then you just have to remember 1 half and then two derivatives. So, DDS, now this is going to be 9 times negative s squared, plus s plus 2, s times s plus 6. Okay, and the s plus 4 squared gets canceled. You might think, oh, since we're only doing s plus 4, then you would do s plus 4, and then, this bottom part, it would be the s times s plus 6, and then you do the s plus 4 squared, right? You might think like, oh, you only do s plus 4 and you cross this out once. But if you did that, this is still going to be s is equal to negative 4. If you plug in negative 4 here, it'll be 0, and you can't have zeros on the bottom. So you do have to cross out the whole s plus 4 squared. Okay, so let's delete this. Okay. So, s is equal to negative 4. Now, also over here, I need to close this off. So this is the end of the bracket. Okay. Now, this is a derivative, right? You're going to have to take a derivative here. I'm not too much of a fan of when everything is factored out. So I really like doing it like this. I actually like multiplying the 9 through. You don't have to, especially if you're like really good with finding derivatives. But I wasn't the best, right? I wasn't, if it was like a little bit off, I would always get confused. So if it was ever in a factored form, I would always get confused. So I had to always multiply it through. So it's going to look like this for me. S is equal to negative 4. And that's completely fine. If you want to write it like this, or if you want to write it the other way, both are equally fine. You're just taking a derivative, so you could write either or. But to find the derivative, you have a numerator and a denominator. So that means you have to do quotient rule. This is going to be quite a big derivative, but this is really the only hard part of the problem. So the derivative is going to look like this. Negative 18s plus 9. Right, take the derivative of the top and then multiply it by the bottom part, s squared plus 6s minus, now you take the bottom part, you take the derivative of the bottom part, which is 2s plus 6, and then you multiply that by the top part. Negative 9s squared plus 9s plus 18. Right. And then the bottom part is going to be s squared plus 6s, and that's all going to be squared now. Now, as you can see by this problem right here, it is really, really big. And to take another derivative of this, let's say you had the s plus 4 cubed, it would be really, really long to do. You don't want to have to, multiply everything through and then simplify. That's why he doesn't give you something like s plus 4 cubed. It would be way too long, and it would probably take like 30 minutes to an hour just to do two derivatives. But next semester, it might pop up once. So you have this. And then you just have to plug in s is equal to negative 4. Yep. So over here, you have s is equal to negative 4. Right? Now, as I said, you could just do this on your calculator. But I will write out what each part turns out to be. The first part is 81. The next part is negative 8. This is negative 2. This is negative 162. And the bottom part comes out to be 64, right? You could just write the whole equation there. But I just did it by parts because for me that's easier. This would come out to be negative 648 minus 324 divided by 64, and this will become negative 243 over 16. All right, so we have all of that. The last thing that we have to do is K4. Now K4 is much easier than K3 because you do the same thing but without the derivative. You do 9 times negative s squared plus s plus 2. Right. And then you have to do s times s plus 6. For s is equal to negative 4. This one's a very easy one. No derivative, and you just cancel out the s plus 4 squared. This will become negative 162 over negative 8, which is 81 over 4. So, you now have K1, K2, K3, and K4. The next step, so you would put all the values over here. So it would be 3 over 16. I'll just write it down over here. You're going to get xs is equal to 3 over 16 times 1 over s plus 15, 1 over s plus 6, minus 243 over 16, 1 over s plus 4, plus 81 divided by 4, times 1 over s plus 4 squared. Okay? So you have this. The next step is to take the Laplace, and I think the way you write it is something like this. Do like the brackets, and then you write a little L over here in the script. Or this might be, this is either the Laplace or the inverse Laplace. I think this might be the inverse Laplace. So you're going to take the inverse Laplace of this equation. The best way to say it is just you're going to transform this equation. So you have the 1 over s. If it's 1 over s, it just becomes 3 over 16. This is getting it in the e format, not the u of t, or like the step function format, by the way. So 15 e to the negative 60. The step function stuff comes after this. Negative 243 over 16 e to the negative 4t plus 81 over 4 t e to the negative 4t, and I'll explain this. So 1 over s, when you take the when you transform this, it's just going to be the number. 1 over s just goes away. 1 over s plus 6. When you have 1 over s plus 6, it becomes e, and then you take negative of whatever this value is, so it becomes negative 6t. Same thing over here, s plus 4 is going to be e to the negative 4t, and if you have a squared, it's going to be the e to the negative 4t again, but you're going to write t on the outside as well. And with that, I could also just write this down here. These are just kind of things that you have to know. This isn't too bad. If you have 1 over s, that becomes 1. 1 over s minus a is equal to e to the at. And then if you have n factorial of 1 over s minus a, s minus a n plus 1, this is equal to e a t to the n. And over here in this part, we only had 2. So basically what that means, n is 1 because it's being squared, so it's 1 plus 1, which becomes 2. That means also over here, the top part is also 1, and 1 factorial is 1, right? And this n over here is just going to also be 1, so that's why there's just a t, and it's not like a t squared or anything like that. And then the EA of t, that just follows the basic rules. Right, so this is something a little bit more complicated, but as I said, he's most likely not going to put anything above, like, something squared. It's not going to be cubed, most likely not going to be to the 4th either. I've never seen a problem to the 4th. So you will most likely, have a very simple problem over here where the n is going to be 1. So, this one isn't too bad. As I said, it's a lot of math. The last step is a little bit hard, but it's the last step is it's not too bad, honestly. It's just that you have to remember like how to do this stuff. And the only real hard part of this problem is doing K3 because you have to take a derivative. But honestly, if you forget how to take the derivative, that's fine. You can always find K1, K2, K4, or whatever order it's going to be in, right? You could always find the values. That doesn't have to be this one, right? Because this one is going to be the hardest one in this case. So just go with what you know. Get that partial credit. Do as much as you can. The next one, so I'm not going to do problem 2 yet. I'm going to save problem 2 and problem 4 for last, because you kind of have to get in it's like the same method, but you have to get in a different mindset. All the other ones are pretty similar to each other. Problem 3, we're going to do problem 3. Problem 3 can be a little bit confusing. Honestly, it confuses me a little bit too. But it's not too bad. This one needs a little bit memorization. So, I think the worst thing that you could do for this type of problem is just write out the question. Don't write this out, right? This is a lot of stuff that you would have to write out. Okay, so let's copy this. Yep. Okay. Yeah. I already wrote problem 3, but that's fine. The top part, which I didn't copy, says consider the system described by the following differential equation. Okay. So this is a differential equation. You guys should know this from, of course, differential equations. Or it should look a little bit similar. So the first part is to find HS. Now this is very easy to do. If you have trouble finding part 3, definitely do part 1 and part 2 because they're very, very easy to do. So to find HS, HS is equal to YS over XS, right? All right, so how do we do this? How do we get YS over XS? So everything that is a Y over here, it's just going to turn into YS. And everything that's an X over here is just going to turn into XS. So I'm going to have to do it like this. And so this is Y triple dot. So that's going to be S cubed YS. Now let me see something. I believe I have some sheets over here on the right of some givens. Yes. See right here. Y triple dot turns into just S cubed YS. And there's a lot of there's this extra stuff over here, right? And that comes in for part 3. But we're only gonna write the YS. This is not the zero state response. Let me look at the problem. Sorry, zero input response. We're looking for the transfer function of the system HS, right? So we're only considering all the YS's and all the XS's. When we do the zero state response and the zero input response, no, actually, when we do the zero input response, that's when we're going to consider the Y 0 minus. So just don't worry about that for now. Okay. Let me just erase this stuff. So we're going to write this as S cubed YS because there's 3 dots. This next one is going to be plus 16 S squared YS because there's 2 dots. And we're just going to go down the line. Plus 84 S. Yes, 84 S YS because there's 1 dot. And then the last one, there's not going to be an S because there's no dots above it. 144 YS, right? There's no S on the outside here. And this is going to be equal to the X part. So this is going to stay outside. 144, this is going to turn into S squared XS plus 4S XS and this is going to be 3 xs. Right? Okay. So now, we can rewrite this. This is the long way of doing it. Don't do the long way. I'm just gonna show you why I would always get confused with this too. I'd always think, oh, how am I supposed to divide it? So I'm gonna show you guys how to do it, but don't, just keep this in your mind for the test. Because there's a much easier way to do it. XS times 144. S squared plus 4s plus 3. Alright, so you have this. You have your ys and you have your xs. We just took it out because it was being multiplied by all parts of the equation. Now we're trying to find ys over xs. So basically, we're going to divide the xs over here and we're going to put it over here. Right? And then we're going to put this one over here on the bottom. So the xs is going to be on the denominator, and the values that were being multiplied by ys is going to go in the denominator over here. So this is going to be ys over xs. Right, and then we're going to write this 144 over s squared plus 4s plus 3 divided by s cubed plus 16s squared plus 84s plus 144. So as I said, do not write this part over here. You don't have to. It's just for you guys to be able to see why one part goes on the denominator. Just know for the test, the stuff that's being multiplied by ys goes in the denominator, and the stuff that's being multiplied by xs goes on the numerator. So this is really just a two-step problem. That's a lot of credit that you could get for this problem right here. And there's going to be even more credit that you can get for part 2. For part 2, it's even easier than the first part because you're only multiplying the equation by one thing. It's saying find the zero state response. Excuse me. The zero state response of the system, YZSR. So what we're going to do is we're going to focus on this and the formula we just found before. X of t is equal to u of t. Now, let me just rewrite that. X of t is equal to u of t. Now, if we were to transform that, we have xs is equal to u of t becomes 1 over s. Now, I believe there's another sheet for that as well. Let me take a look over here. Yes, over here. U of t is equal to 1 over s. The delta function is equal to 1. R of t is 1 over s squared. This p of t is 1 over s cubed. And these ones I had already shown before. Right, this one was the end of problem 1. If you want, you can also look up Laplace transform table. And you could go over here. Let me open this. Okay, so as you can see over here on chegg.com, delta t is equal to 1, u of t is equal to 1 over s. T u of t, or as we know it, r of t, is 1 over s squared. This over here, the tu of t, that comes in next semester, so don't worry about that. Just write it as r of t. It won't have the p of t function, but 1 over s cubed is p of t. So just keep that in mind. So we're going to go back to this problem. Xs is equal to 1 over s. All right, and that's when you take the Laplace. And we're trying to find the y0 state response of s. And to find that, you need to do hs times xs. So we have xs over here, and you're going to ask, well, what's hs? Hs we already found in the first problem, right? Hs is ys over xs, so this is hs over here. Or sorry, I didn't circle the whole thing. This is all hs. So the very simple answer is y z s r times s. So I'm not writing my z's like this. This is a nicer way of writing the z's. It's going to be, honestly, just copy exactly. Don't even multiply it, honestly. Just leave it unmultiplied. Show you what I mean. So you're literally going to do that, and you're going to say times 1 over s, and that's your answer right there, right? That's full credit. That's full credit for doing part 2, and that was literally like 2 steps. I wouldn't even consider that 2 steps, like 1.5, 1 step, because this is very simple to do. You could do that in your head even. Now, part 3 is a little bit more complicated. Part 3, we have to find the 0 input response. And there's quite a few steps to doing part 3. So if you want to try it out, like on the test you can, but it does take a few steps. So if you don't get all the steps, that's fine. Just do as much as you can. As I say, partial credit is the most important thing. So if this takes you too long and you forget something, just go on to a different problem and come back to this. So as I was saying before, right, you have this Laplace of y triple dot, and it becomes this really big thing, and that's actually going to come in for this problem. So we're going to go back over here. So we're going to take the Laplace of each part. We're going to take it. Now, he did it a little bit differently for us when we were taking signals and systems, but both ways are valid. So if you take the Laplace of the first part, it's going to be s cubed ys. And it's going to look pretty much the same, but all the other y values are not going to say s, they're going to say 0. So minus s y, oh my god, s y dot 0 minus y. This is a lot of stuff to write, so. And then we're going to do the Laplace of the other part. Or no. Oh, okay. So we have this. And for this problem, actually, we do have y0, y dot 0, and y double dot 0. Right? It's over here. We have the values for each of these. So we're just going to plug those values in. Here. So s cubed, and this is going to stay as y of s, but the other values are going to be plus 8 s squared minus 16s plus 4. All right, and we're going to do that to each part. So the next part will be to do the Laplace of this one, 16y double dot. You could look back at that sheet on the right side. I believe he gave it to you guys in class. I'm not too sure, or maybe he posted it online. But if you guys don't have it, of course, you could just look back at the video. So this is going to be 16. And it's going to be s squared ys minus s y 0. It's going to be minus y dot 0. Right, because the 16 is being multiplied by this whole thing. That will become 16s squared ys plus, hold on, plus 128s minus 256. Alright? And we're just going to keep going down the line. The next part is going to be the 84 one. So it's going to be sys minus y dot of 0 is equal to 84s ys plus 672 and then the last part is going to be 144 ys is equal to, of course, 144 ys. Alright, so now you have all the parts of it. Luckily for this problem, for this problem you don't have to do the excess. You only have to find the Laplace of the y of s. With that being said, so yes, okay. So what you're gonna do is you're going to add each of these parts together, right? All of this, you're just going to say this part plus this part over here plus this part over here plus 144 ys. Okay. And okay, so there's going to be some values with s's. There's going to be constants, and there's going to be some with ys, right? And a combination of a few of those two. You're going to have something like this, where you have a constant, an s, and a ys. But it's going to look something like this. Yep. Okay. I guess I could write the whole thing. I don't really need to. S cubed. Let me zoom in a bit. So we're going to write s cubed ys plus 8s squared minus 16s plus 4 plus 16 s squared ys. Alright, this is going to be like way too long to write. You don't have to write this, right? Dot, dot, dot. What we're going to do is we're going to actually add all of this stuff up. So anytime you see a constant, like just a constant, you're going to add those stuff up. And if you have a ys, just keep that a little bit separate. So what I mean is here. When you have anything multiplied by a ys, take out the ys, and it's going to be s cubed plus 16s squared plus 84s plus 144. And this is very easy to see from this, because it's literally only the first part of every single equation. Just take out the ys there and put it all in one area. All right, and then the next part is going to be plus 8s squared minus 112s. Whoops, that doesn't look like a 1. 112s plus 420. Nice. This is basically just adding up all the constants, right? Negative 256, 4, and 672. You're going to add up all the parts that just have s, which is just 1 apparently. Sorry, actually, there's 2 of them over here. Negative 16 and 28. Or sorry, negative 16 and 128. And then there's going to be 1 s squared. All right, so now you have this equation. So you could bring all of this to the right side where the 0 is. So it's going to look like y s times s cubed plus 16s squared plus 84s plus 144, and that's going to be equal to negative 8s squared plus 112s plus minus 420. And then all you're going to do is divide. So that you get ys. This is, I forgot to write, this is a 0 input response. You could write that for all the other parts. Negative 8s squared plus 112s minus 420 divided by s cubed plus 16s squared plus 84s plus 144, and that's going to be your answer. So this part is quite long, and it's like a little bit hard to remember, but you guys can get like a lot of credit for part 1 and part 2, and if you guys do forget this, you can just come back to this whenever you want, and go on to the other parts, which might give you more credit. Don't dwell on this, really. All right. So that's question 3, I believe. Yeah, question 3. Let me see something. There we go. All right, question. Which one did I want to do? Question 5? No, question 6. Okay. Question 6. Question 6 is pretty short, not gonna lie. Okay. This one's really short. So if I remember correctly, he said question 5 and question 6 are basically the same thing. Question 5 and question 6. Yeah, this is question 6. Yeah, both of them you convert you convert the step functions, or ramp functions, whatever. You convert the functions into this Laplace, and then you like add, multiply, whatever it is. This one too, oh my god, hold on. You're gonna convert the functions into Laplace form, and then multiply, add, whatever it is, depending on this part. And yep, and then you're gonna, for this one, you have to convert back. Do you have to convert back? Oh, you have to convert back for both of them. Never mind. Okay, so these are basically the same thing. He said that he'll probably put like one or the other. So if you're prepared for one, pretty much you're prepared for the other as well. But we're gonna do both of them. Problem 6 is easier, just because you could do more of the problem on one line. But they're kind of equally as hard, honestly. Problem 6. For a linear, time invariant, causal continu... Okay, it doesn't matter. Let's find the x of t function. Xt. I don't even have to look at like what the question is asking me. I just know, okay, this is an x of t, this is an h of t. We're gonna have to multiply them together. We start with this, negative u of t minus 1, because it goes down to negative 1 at t is equal to 1. The next part is going to be plus u of t minus 3, because it goes back to 0. Plus u of t minus 3 at t is equal to 3. And then we're going to find h of t, which is equal to negative 3 u of t minus 3. Whoops. Plus, I know on his, he does like plus 3 u of t minus 4 plus 2 u of t minus 4, but that's basically just saying this, 5 u of t minus 4. Yeah, because this goes up to 0 and then up by 2, so you could just say that that's 5. Up 3, up 2. And then it goes back down to 0, 2u of t minus 5. Alright, so we have all these parts. Now we have to convert it to ES domain, or whatever you want to call it, Laplace. You have to take the Laplace. This is going to be negative. U becomes 1 over s, and the t minus 1 will become e to the negative 1s. That's how I always do these problems. You could also just say e to the negative s. That's how I always do these problems. I just do it step by step. Okay, this next part is positive. What is the function? It's going to be u, so that's 1 over s. And it's at t minus 3, so this is e to the negative 3s. Right? Just keep doing it like that, and it'll be very simple. H of t, same thing. Hs is equal to, so there's a constant outside, so this is going to be negative 3 over s. Because it's also because it's u, and this is going to be at negative 3. This is going to be 5 s e to the negative 4s. And this is going to be 2s e to the negative 5s. And I believe there's a guide on how to do that over here as well. Yeah, right over here. This is basically like what I just did to find the e part. It's a little bit confusing, so just do it like how I did it, right? Just say it's at t minus 3, so it's going to be e to the negative 3t, right? Like this part. You don't have to remember that formula of x of t times u of t or whatever it was. Just know, okay, it's at t minus 3, it's at t minus 3, it becomes e to the negative 3s. Alright, and then we have to do h of s times x of s. And I'm not gonna rewrite each of these parts. I guess what I can do I always forget about this. I have the selection tool. So let me just select all of this. Nope. Nope. Okay. So that's this part. This is equals, nope. And it's going to be multiplied by excess, which is over here. I'm just going to write it on the bottom. Multiplied by Control C, Control V. Nice. Okay, so we have that. Write this parenthesis a little bit better. Alright, so it's HS times XS. Okay. We're going to multiply these two together. This really isn't that bad. So this is going to be HS times XS, which is equal to so this times this is going to be 3 over s squared e to the negative 4s. The next part is going to be negative 3 over s squared e to the negative 6s. Minus 5 over s squared e to the negative 5s plus 5 over s squared e to the negative 7s plus 2 over s squared e to the negative 6s minus 2 over s squared e to the negative 8s. Right, so this is your equation. You can combine some of these values because some of them have the same base. All of them have the s squared in it, but you know, this e to the negative 6s and this e to the negative 6s, these two can be, oh wow, I did not circle that. These two are actually the only ones that can be combined. I don't think there's any other ones that have the same value. Negative 4, negative 5, negative 7, negative 8. Yep. So if you combine these two, this is equal to, whoa, what is this? 3 over s squared e to the negative 4s minus 1 over s squared e to the negative 6s minus 5 over s squared e to the negative 5s. You might want to like reorder these two, right? So it's in order, but it doesn't really matter. It's not like you're graphing it. Plus 5 over s squared e to the negative 7s plus 5 s squared e to the negative 7s. Yep. Plus 2 over s squared e to the negative 8s. Right. So this is your function. You're gonna have to take the inverse Laplace of this. Whatever. And okay, so luckily these are all these are all s squared, so they're all going to be ramp functions. So it's going to be 3r t minus 4. Right? Yeah. If you do this, the s squared becomes the r, the 3 goes on the outside, and this is at t minus 4, so you could also do this the other way around. 5r t minus 5 minus r t minus 6 plus 5r t minus 7 minus 2r t minus 8. Right? So really, not that hard of a problem, just a lot of writing, and when you have to do this multiplication over here, that might get a little bit confusing, but just do your best. But this one's really not that bad of a problem. Problem 5 is a little bit longer, I would say. Yeah, it's a little bit longer. And maybe like a little bit tougher, but not like god awful or something like that, right? This is still within reason. Problem 5. Yeah, pretty much everything in this problem is just split up. Rather than it being like combined. You actually have to combine it yourself with this part. So let's do that. First, let's change this into. Let's find the Laplace of each one of these. This is going to be 1 over s e to the negative 2s. This one is going to be. Ooh, what is this one going to be? E to the negative 3s. If it's a delta function, this becomes a 1 on the outside. There's no s. But the t minus 3 just becomes an e to the negative 3s, right? I'm going to write it on the left over here. U of t plus 1, this one's 1 over s e to the s, right? This one becomes 1 over s, 1 over s e to the negative 5s. And this one over here is just going to be two parts. This one's going to be e to the negative 2s minus e to the negative 4s. Alright, so you have all of your parts. Now you just have to multiply this. So you have your h of t function, and how he writes it is actually very nice. I really like how he writes it. He just does h4 5, right? And that's the easiest way to write it. And you can write this h4 5, and that easily means h4 minus h5. So h4 is 1 over s e to the negative 5s. And then h5 is minus e to the negative 2s minus e to the negative 4s. Right? And then the next one is going to be h345, which just means that you're going to be multiplying h3 by whatever we found over here. So, yeah, I'm not gonna write out h3 times h45. It's right there. This is h3, and it's being multiplied by this, right? So the answer to that is going to be 1 over s e to the negative 5s minus e to the negative 2s plus e. That's h45. This is going to be 1 over s squared. This is going to be 1 over s squared minus e to the negative 4s. This one is going to be 1 over s e to the negative s. This one's going to be 1 over s e to the negative 3s. And I think I copied that. Yep. So that should be correct. E. Next one is going to be h2, 3, 4, 5. Right, because that's the next step over here. You're going to do negative h2, or just remember to do this negative, and you're going to add it to h3, 4, 5, which is very, very simple. This is almost not even a step. E to the negative 3s, and then you just copy this stuff. Alright, Control C, Control V, and this is going to be plus. This is negative 3, and then I can just erase this little, whatever that is. Alright, so that's h2, 3, 4, 5, and the last thing is to do h1 times this whole equation. To do that, the answer is going to be h1, 2, 3, 4, 5 is equal to negative 1 over s e to the negative 5s plus 1 over s cubed e to the negative 6s. Yeah, e to the negative 6s minus 1 over s squared e to the negative 7s plus 1 over s cubed. No, this is s squared. I keep writing that as cubed. It kind of looks like it cubed on my sheet. E to the negative 5s. Alright, this is your h1, 2, 3, 4, 5. That's all of part 1. This is a very nice equation right over here. And you can see why this is like pretty much the same thing as question number 6, just with more steps, right? This is all done in one line. Over here, everything is just like given, and you just multiply this part by that part. But for this one, you have to multiply it individually and do it step by step. The next thing to do, what's the next thing? The next thing to do is part 2, which this is very easy. So before it had a u over here, and if you did that, then it would be 1 over s, right? And the 1 over s would multiply here, and it would be 1 over s to the 4th. And you definitely don't learn 1 over s to the 4th. The most you learn is 1 over s cubed, because we know that that's p of t. Anything after that, if you ever get a 1 over s to the 4th, you know that the answer is wrong, because there's nothing that we learn that's 1 over s to the 4th. I don't even know what that would turn into. So make sure everything is 1 over s cubed and below. So we have the, what is this? This is h of t, by the way. This is h of t. Sorry, this is h of s. Now, he's asking for y of t, and we know that y of t is equal to h of t times x of t. But we only have it in h of s right now, and so we're going to keep that like that. This x of t we're going to change to x of s is equal to, so delta t plus 2, that's going to turn into e to the negative 2s. Or no, is it going to be positive? I think it's going to be positive. Yeah, it's going to be positive 2s. Right? Okay, so we have that. So we're actually going to find y of s is equal to h of s, x of s. This is going to turn into, what is this going to turn into? I forget already. Oh, yeah, you just multiply them. So have it right over here. it's going to turn into negative 1 over s e to the negative 3s plus 1 over s cubed. Right, if this was a u of t function, then this would be s to the fourth, and we don't want that. E to the negative 4s minus 1 over s squared, e to the negative 5, e to the negative 5s, plus 1 over s squared, e to the negative 3s. Alright, this is our y of s function. Now we just have to change it into y of t, which is very simple. This first part is going to be, okay, so 1 over s is u, and this is going to be t minus 3, right? You could just do this in your head, honestly. It's not, you don't have to write a formula for each step. This is going to be s cubed, which is our first instance of seeing this p over here. You don't really see p too much. And we actually, I don't think we ever work with p when like drawing or something like that. It only goes up to r. So this is a very rare occurrence. P of t minus 4. This is going to be minus 1 over s squared is u. Sorry, that's r. R of t minus 5. And this last one is going to be plus r of t minus 3. Now, if I remember correctly, on the sheet, it says like t minus 1. Yeah, you can see negative r of t minus 1. That's wrong. This should be 3 because everything else is right over here. Oops. Yeah, you can see negative u t minus 3. That's fine. P of t minus 4. That's fine. Negative r of t minus. This one says 3. Maybe I wrote that wrong, honestly. This is r of t minus 3. This is t minus 5. No, this should be t minus 5. He wrote. Yes. So right over here, this should be a 5, right? 1 over s squared e to the negative 5. That's r of t minus 5. Or maybe it's this one. I'm not too sure. You guys can fact check me on that one. This isn't too big of a deal. But this negative r of t minus 1, this should definitely be negative 3. I believe this one matches up with this one. This one matches up with this one. This one matches up with this one. This one says 3. This is 3. This is 3. This is 3. Yeah, maybe I did something wrong. Maybe it is 3. Maybe it is 5. Just fact check me on that one, guys. But anyway, this problem isn't too bad, even if I did get like this part wrong, this t minus 5. That's not too big of a deal. That won't have too many points taken off. So problem number 5, problem number 6, very easy problems, very nice to do, and offer a lot of credit. So we went through the easier ones, the ones that are like pure math and are like, if you're gonna transform something, it's very easy to transform like this u of t, right, into 1 over s, or it going backwards, whatever it is, the inverse Laplace. These are very easy to do, and I would actually start off by doing these because this is probably where you're gonna get your most credit, especially if you're good at just like writing stuff in your calculator and just multiplying really quickly, right? Mental math. Now we're gonna go on to the ones that I think are harder, the ones that are more conceptual questions, which still do a bit of math. But these are circuits, I would say P of 2, sorry, P of 2. Question 2 is the hardest. I would think that's the hardest question, like, on this test, just because there's a few steps and it's conceptual. And then question four is honestly not too bad. It could be even one of the easiest problems, um, right up there with question 5 and 6. So we're gonna start with question 2, and then we're gonna move on to question 4. Question 2. What does in purple? How many of you guys like the color purple out there? Question 2. Okay, so question 2, let me copy this. My favorite color is black, honestly. I know that that's like not a color. It's white and black are shades, right? But I usually like saying that. And if not the color black, I like the color brown, honestly. Problem 2. Okay. But I know some people like, I already wrote Q2. I know some people like the color purple. I mean, it is royalty, so fair enough. But anyway, problem 2. In the network below, the switch S is moved to position 1 to the position 2 at t is equal to 0. All right, so we're going to find VC0 minus and IL0 minus. So basically, okay. This first part, I'm going to tell you, is very easy. If you don't like these kinds of problems, I would suggest at least doing part 1, because part 1 is really easy to find. It's literally just like redrawing the graph, or sorry, redrawing the diagram, and just like solving out. Like it's really not that bad. Okay, so it's saying that this is position 1. This part over here is position 1, and then this part over here is going to switch to over here. So I know a lot of you guys are taking electronic systems. Not even electronic systems. In circuits 2, anybody who's taken Moro has seen this type of problem. I don't remember if Amin was teaching that class, and I don't know how he taught that class, but I took Moro. And Moro always says, okay, so imagine this circuit before t is equal to 0, it was left like this for a really, really long time, right? Like infinitely amount of time it was left like that. So it kind of like helps you to understand that, okay, first of all, this is the circuit, plus minus 4 volts, right? This is the first part of the circuit right over here, right? You can see since this part is not connected, this capacitor isn't attached to anything over here. This is an open wire, and this is only like connected in one on one part. So it's basically like this wire doesn't even exist, right? So this is 1/4 farad, and then there's going to be another. What is this? 2 volts. This is going to be another, like its own circuit, basically, because the wire in between them doesn't exist. This is V0T plus minus 1/4 ohms, 1/8 ohms, henries. All right, and this is basically how it is. For T is less than 0, the switch was left like this for a really, really long amount of time. So it was basically in this form for a really long amount of time, and you'll be able to calculate the values for VC0 minus and IC0 minus. So for VC0 minus, honestly, you don't even have to calculate it. VC0 minus. So if this voltage source is connected to this capacitor, well, what happens? Thinking of it logically, a voltage source connected to a capacitor, all the voltage is going to go to the voltage source, right? The capacitor is going to keep building up charge until it matches the 4 volts. So if this is connected for a really long amount of time, all the voltage, all the 4 volts is going to go into the capacitor, so this means this is 4 volts. Now if you were looking at this one over here, so an inductor is basically a wire, right? It's just a wire that's winded up, and it collects all the current. A capacitor charges up by the voltage, and the inductor charges up by the current. With that being said, we know the voltage here, and we know that there's a resistor here, so we could find the current. We use I is equal to V over R. So IC0 minus is equal to the voltage, which is 2, over 1/4, which is the resistance. So this is equal to a whopping 8 amps. All right, so we find VC0 minus and we find IC0 minus. Very, very simple. And you could get a lot of credit for that. Now you have to sketch the Laplace transform circuit for t is greater than 0. This one's a little bit more complicated. So for t is greater than 0, this is going to switch. So basically this voltage source is not connected to anything. It's connected by this line, yes, but over here it's not connected, so we just kind of get rid of it. There's no voltage source anymore. And this capacitor is in parallel with this inductor, and it has this voltage source and this resistor over here. So let's do this. II. T is greater than 0. The diagram will now look something like this. Come on. And then we have this voltage source plus minus. Then we have this resistor. 1/4 ohms. Plus minus. I'm not going to write everything. This is 2 volts. Actually, no, I will write everything. Because why not? 1/4 farads. And this is 1/8, I think. Yeah, 1/8 Henry. All right. So now that we have the diagram after t is greater than 0, sorry, for t is greater than 0, not after t is greater than 0, that doesn't make any sense. We are going to look to this over here. I know on the Moodle, if you go into like chapter 6, like Laplace transform, whatever the Laplace transform folder is, and you go to the first link, it shows this, but it shows the admittance, right? We don't want the admittance. I even got confused. I was just like why for the admittance it said ys is equal to 1 over SL, and I thought that that's the equation we use. No, we're going to be using this equation right over here. The ZLS is equal to SL, right? And for this one, it's going to be, yeah, okay. So we have that. And you're going to, yeah, just remember to use this diagram where it has this Z over here. Just make sure it has Z. If it says Y, just don't use that diagram. You just have to like flip this, right? 1 over SL would then become SL. But use this diagram for this. No matter what, if you change it into a voltage source or a current source, it's going to be SL. For this one, if you change it into a voltage source or a current source, the impedance is going to be 1 over SC. Okay. Now, question for you guys, what do you think we're going to change it into? If you look at this diagram, what do you think you're going to change this into? So you could pause the video and just like think of it a little bit longer, but it's going to be changed into a current source. The reason for that, so you might be thinking, oh, there's a voltage source over here, right? So the easiest thing to do is to, hold on, where is my cursor? We have a voltage source over here. The easiest thing to do would be to change it into a current, into a voltage source, right? But if you were to change it into a voltage source, it would be something like this, right? And you would have that, and then you would have this over here. Something like this, right? Maybe the direction is wrong, but I'm not too sure. So it would be something like this, and it's like, oh, well, we can't really combine those because it's a voltage source in series with a capacitor, and that's in parallel with an inductor in series with a capacitor. With an inductor in series with a voltage source, right? So you can't really do anything there. The best thing to do is to change it into a current source, because if you have two current sources in parallel, you could combine those. And if you have two impedances in parallel, you could also combine those. So we're going to go, so for this capacitor, C, this is going to change into something that looks like this, right? A capacitor in parallel with a current source. The current source value is going to be C VC 0 minus, which is equal to the capacitor value is 1/4. VC 0 minus, which we found before, is 4. So this is going to be 1 amp. Now, why do we use C VC 0 minus over here? Take a look at this. Over here, the capacitor, C VC 0 minus, right? And then it also tells you which direction to put it in. For the capacitor, it points up. For the inductor, it points down, right? So just remember that all the time. This is a very important sheet to know, and it's a little bit complicated because there's a whole bunch of stuff going on. Maybe he'll give you an equation sheet during the test, hopefully. But this is very important to know. And the next part over here is we had to find the impedance value, Z. And to find the impedance value is going to be 1 over SC. So let's go back over here. 1 over SC. Scroll down a bit. So over here, the capacitor, we have to change this into impedance. So Z, ZC of 0 minus. I don't know if he writes it like that. It might just be ZC. ZC is equal to 1 over SC. The capacitor value is 1/4. So it would be S over 4, which would be 1 divided by S over 4, which turns into 4 over S. Right, because of keep, change, flip. You're going to do the same thing to the inductor over here. For the inductor, L, this is, you have an inductor, this is going to be facing down. I L 0 minus S is equal to A over S. The inductor value is equal to S times L. L is 1/8, so this is S over 8. Right. Okay. We have these two things. Now we have to actually rebuild the circuit over here. Just kind of have to combine these two. So we're going to go up here. Nope. Over here. Okay, so we have these parts. To redraw the circuit, we're going to do capacitor 4 over S we're going to put these two next to each other, the capacitor and the inductor, because we're going to combine them anyway. They're in parallel. 8 over S. And then we have one current source that goes like this, and that's going to be 1 amp. We have another current source, this time facing down. This is going to be S over 8. S over 8. And then we have the resistor and the voltage source, which I forgot to draw. Alright, so we have that. Plus minus 2 over S 1/4. This is definitely going to be like my longest video, but don't let that scare you. Honestly, this is just kind of a lot of stuff to go over, right? And there's like two different mindsets. There's the equation way, which we went over, and this is kind of the I forgot the word for it, but you have to use like out of the box thinking, and you have to do transforms and whatnot. So, but it's honestly not that bad of a quiz of a final. It's like medium, I would say. This is a medium final. Anyway, getting back to this. Okay, so we have these two values over here. So what we're going to do, we have two impedance values. Just remember that these are impedance values, so we can combine them. Before they were just capacitor and inductor values, which you can't combine, but if it's an impedance, you could also, by the way, draw an impedance like this, just as a box. So this is going to turn into 4 over S in parallel with 8 over S. So I could go through the whole thing. First you do product over sum, and then you solve out for it. I'm just going to write the answer. So I could probably write the first part, the product, I wrote something wrong here, didn't I? This is 4 over S. Oh, I think this is S over 8. Wait, hold on. Yes, SL is... Yeah, okay. So this is... I'm sorry, I wrote this wrong. This is supposed to be S over 8. And this is supposed to be 8 over S. I just switched these two. S over 8 and 8 over S, and then this one as well, this one will turn into S over 8. S over 8. Alright, so you have these two values. The product is going to turn into 4. What is it, 4? No, it's going to turn into 1/2 because 4 over 8, right? And then the s's cancel. So this is going to turn into 1/2. The bottom part is going to be 4 over s plus s over 8. That's going to, you have to do like common denominator stuff. This is 1/2. This is 32 plus s squared over 8s. And then this turns into 4s over 32 plus s squared. All right, keep, change, flip. Once you find that, okay. So once you find that, you also have to find the combination of these two. This is very simple. How do you find the combination of these two? Okay, so this current is coming in. This is just KCL. This current is coming out, and it's going into here, we'll say, right? So KCL, this one this one minus this one minus this one, right? I1, let's say that this is I1, I2, and I3. I1 minus I2 minus I3, which is equal to 0, and we're trying to find I3. So this is I1 minus I2, which is 1 minus 8 over s, and we could combine that into s minus 8 over s, right? You multiply the 1 by s over s. Common denominator, s minus 8 over s. Okay. We have that now. After that, we can combine the diagram into a current source that's facing this way, which is the s minus 8 over s. We have an impedance, so we're just going to draw that as a box, and that's attached to the voltage source, I think it's like that, and the resistor, right? But this is, hold on, let me just write 4s over 32 plus s squared, right? This is a current source and an impedance. This is a voltage source and a resistor, right? Well, this is also an impedance now, but whatever, we'll just say that this is a resistor for now. It's an impedance. And you can't combine this, right? You literally can't combine a current source with a voltage source in this way. But these two are in parallel. If you guys remember, this is the Norton equivalent. Norton. So we have to find the Thevenin equivalent. We just have to do source transformation. This is just source transformation. So we have to get it in this form. Plus minus V Thevenin. And then we have the Z Thevenin over here. Z Thevenin. Right, and that's attached to the rest of the circuit. But anyway, so Z Thevenin, that stays the same. Z Thevenin is equal to 4s over 32s minus, oh my god, I don't even know what that says. Oh, that says s squared. Okay, 32. Yeah, that's bad. Okay, so 32. Just erase that. 32 plus s squared. All right, 32 plus s squared is plus, right? Yep, plus s squared. So that's our Z Thevenin. Now our V Thevenin is, we're going to, so we have V is equal to IR, or V is equal to IZ in this case. we're going to take the current source and multiply it by the impedance. So this is going to be S minus 8 over S minus 8 over S, times 4 over S over 32 plus S squared. Not going to bore you with the details, but these two cancel out, and the final answer will look something like 16s minus 64 over S squared plus 16. Okay. Almost done with this problem. Okay, so we have that. And the final thing, the final Laplace transform, will look something like this. 16. You have the plus and minus V7 and Z7 in, right? And that's going to be plus and minus like this, I think. Yep. Resistor or impedance. I'm just going to write V7 in. We just found it up here. This is, where is it? This is V7 in. And then we also have Z7 in up there as well. This is a voltage source. What you do is to find the Laplace transform, the voltage source was 2. You just divide it by S. The resistor is 1/4. That just stays the same. For part 3, we have to do, I don't even know, where is this? Part 3. Find the Laplace transform output V0s. Do not expand the function into partial fractions and do not find the coefficients. Okay, so basically, we have 2 voltage sources. So we're just going to add those two together. We're just going to say V7 plus, it's minus because they're facing in the opposite direction, right? So we're going to say, yeah, we choose like this direction, right? We move over. Oh, we see a negative over here. Okay, so this is negative. We see a positive V7 over here, so that's positive, right? So we have V7 minus 2 over S. This is divided by the resistor values, and these are both positive, Z7, because you could just go like this, plus minus, and both of them are going to be positive. Or even, actually you would write it like this, plus minus, because we're starting from here, and we just move over here, plus, right? Okay. So, Z7 plus 1/4. Okay. So we have these values. Let me just make sure I'm recording. Almost 2 hours. 2-hour video. Nice. That division sign does not come in yet. Wait, what did I just erase? Okay. This division sign is, ooh, nope. So Z7 plus 1/4, right? To find the current, we'll say the current over here, IS, to find the current, it's just literally the division of these two. That's why I wrote the division symbol for. This is V over Z, right? This is equal to IS, and you might be thinking, oh, why are we finding IS? We're supposed to be finding V0S. V0T was over here, right? V0T was over here, and this is V0, sorry. This is V0S. And to find V0S, you do the resistor value, 1/4, or the impedance value, times IS, right? V is equal to IR. So you have to find the total you have to find the total current, then you have to find the voltage going through that resistor, which is just 1/4 times IS, right? So this one's a a really big problem. I wouldn't like blame you guys if you didn't know how to like do this. But if you do remember like all of this stuff, you'll be fine for the final. At most, do part 1. Part 1 is the most important thing because that's like a couple steps. But yeah, this one, it's honestly not too bad. It's just that there's a lot of stuff that you have to remember. But I think you guys will be able to do this. I mean, most of the stuff I'm able to remember just like off the top of my head. The U of T's, right? The functions and how to translate them. And source transformation, you guys learned, last year or something. You have Norton to Thevenin, right? That's the source transformation. This I1, I2, and I3, that's just KCL. Parallel. All you have to do is just know how to take the Laplace of this. Okay, just remember how to do Laplace. But okay. Anyway, now I'm gonna go to, what should I go to? Q4. Okay, so Q4 I was like really confused about on how to do, because this one I like forgot. I honestly just like forgot how to do this. I had forgotten how to do this 1 and 2. I actually tried to derive this formula. Apparently, you don't have to derive this formula. Over here, he says this over here. So you have to know this formula, and you have to know this formula, right? And this is actually very good. Like you might think like, oh, more memorization. No, this is actually very good because you don't have to derive it yourself. This like took me forever to do. It was really annoying, and then I just like went to him and I was like, how do you do this problem? And he was just like, oh yeah, this is just a given, right? This over here, this is just the general formula for everything. And I was like, oh, that makes this problem like 10 times easier. So let's go over here. Yeah, I would say this is not a bad problem. I'm gonna have to bring this down. So we're gonna start with the capacitor one, because I don't remember if I know how to do the inductor one. It's basically the same thing, right? I just did the capacitor one today, so I know how to do this one. But the inductor one is like pretty easy. Q4 is definitely easier than Q2, especially knowing that you start from here and you just go down, which is like 5 steps. So this is a pretty good problem to do. All right. Control V. Okay, we're gonna go with brown, my favorite color. Okay, so circuit at t is equal to 0, negative. So it's in this form for a very long time. The current source is not here. All right, let's look at this logically. Right, a this isn't even a like algebraic problem right now. You're trying to find the initial capacitor voltage V0 of 0 minus, right? So basically, what is this capacitor value when it's just a voltage source in parallel with a 1 ohm resistor in parallel with a capacitor? So you can think about this in two ways. Oh, I forgot what the second way is. One is you could use nodal analysis, and not like, I don't mean like the full nodal analysis. Nodal analysis and shoot, I don't remember. Um, you could think about this as nodal analysis, or you could think about this as just regular parallel combinations, right? So this voltage source is in parallel with a 1 ohm resistor and in parallel with a capacitor. What does that mean? That means all the voltage is going to this resistor and all the voltage is going to this capacitor. So that must mean that V0 of 0 minus for the capacitor is 15 volts. Right? I think that should be correct. Let's see over here. Yep, VC of 0 minus is equal to 15 volts. The other thing you could do is you could think about this as like two nodes. Right? This is all one node, and this is all another node. So that must mean, okay, so 15 volts is up here, and 0 volts is down here. So that must mean that when you go from this node to this node, there's a difference of 15 volts. So that must mean also that this capacitor has 15 volts in it. So you could think about it like that, or you could think about it like the parallel circuit combination. Either way, it's going to be 15 volts. And I think he's only gonna like give it in these two forms as well. Like the other way, where it was, he had a problem before with the inductor, where it was like the inductor was in parallel with the 2 ohm resistor, and that was like a little bit confusing. So I think he's only gonna give it with inductor in parallel with resistor, and then capacitor in parallel with a 1 ohm resistor. Sorry, did I say inductor in series with a resistor and capacitor in parallel with a 1 ohm resistor? I don't remember if I said parallel before for the inductor. Okay, so we found VC 0 minus just logically. Differential equation of the RC circuit is T is greater than 0. Okay, so for T is greater than 0, this switch is going to go over here to position 2. This voltage source is going to be, you're just going to get rid of this voltage source, so it's going to be a current source in parallel with a resistor in parallel with a capacitor. Alright, so now we could actually start drawing stuff. I'll say VC 0 minus is equal to 15 volts. And I think we could go straight into straight into this. So for the capacitor, the capacitor, we just use this formula. Actually, what we can do is we can redraw the circuit. That would probably be the best thing to do. One half, 1 ohm, 10 amps. Okay, so we have that. I gotta wake up in like 4 hours or something like that. Anyway, so we have 10 amps, 1 ohms, and 1/2, what is this? Farads. dVc, we write the equation here. dVc of t dt plus 1 over RC VCT is equal to 1 over C IT. Right? This is such a savior of an equation because it's like, if you have the parallel circuit combination like this, and it's going to be something like this or the inductor, then you can just go straight into this step. And then you just plug in the values. R, let me just rewrite this. dVc of t. dVc of t is, I think we write V0, but whatever. dt. So 1 over RC, that's going to be 2. This is also going to be 2. This is going to be, hold on a second. Wait, no, hold on. Oh, so I of t is 10 amps. So 10 times 2 is 20. There we go. That's what I was confused about. Now we go over here to our final drawing, which is up here. No, I think it's this one. Yep. So you remember this one from before, this y dot of t. We are looking at this problem. Y dot of t is equal to sys. Honestly, here, let me just copy this. That would probably be the best thing. So we're going to go like that. Where's the problem? See? So this over here is the same thing as this. Y dot of t is also known as the derivative of y of t. In this case, y of t is the same as vc of t. Is going to turn into sys minus y0 minus. So let's rewrite that. This is going to be, let's write it underneath over here. So S times ys, which is V0t, VCT, V0t, it doesn't matter. Minus y0 minus. Y0 minus is going to be, we found it over here, VC0 minus, 15 volts. is going to be minus 15 volts. This is going to be equal to, as I said, this 20 is a voltage source. Sorry, is it a voltage source? It's a capacitor times the current, which is basically the voltage? Oh, well, whatever it is, current source, right? So it's going to be 20 over S. Right, with this type of stuff, you just divide it by S. And I believe, yes, there was one thing I left out. This is 2 VCT. So I'm going to write it over here. 2 VCT goes over here. All right. Plus 2 V0T VCT. And then is equal to 20 over S. S plus 2, this side would be the X of S, but I'm just, I could have written it in terms of Y of S and X of S, but I just didn't. I just kept it as V0 of T, V0 of T. So this is going to be, you have 2 V0Ts, so this is going to be S plus 2 times V0T, whoops, V0 of T, minus 15 is equal to 20 over S, and you do, you're going to you're going to add the 15 to the other side, and then you're going to divide by S plus 2. 20 over S plus 15 over S plus 2. And that's going to turn into 20 plus 15S over S times S plus 2. Oh, look at that. We have an S times S plus 2. That kind of looks like the first problem we did with K1 and K2, right? So this is going to be K1 over S plus K2 over S plus 2. And guess what? We don't even need this top part anymore, right? Because we have K1 and K2. We're not going to solve out for K1 and K2. We just leave it as K1 and K2. But what we can do is we can transform it. 1 over S, we know becomes 1. So this is just going to be K1. And then the K2, this is S plus 2. That turns into E to the negative 2t. Look at that. So we get K1 plus K2 E to the negative 2t. And that's how to do these types of problems. It's like a combination of the first problem and the second problem. So, and I think this one's like much easier to do. You just have to remember. Oh yeah, you just have to remember how to do this transform, right? Like, okay, fine, you know how to do, you remember this equation, but then you have to know how to do the transform. The transform can be a little bit tough. Let's also try doing the other one. Now, I haven't tried the other one. He updated it, and I haven't taken a look at it. So, hopefully I don't get stuck over here. So you have switch S. Okay, is that position 1 for a long time and is moved to position 2 at t is equal to 0. So it's in this position. And it moves to position 2 at t is equal to 0. So let's take a look at this. You have a voltage source, a resistor, and an inductor. That's the whole circuit at first. The inductor is going to be the current flowing through here. It's going to charge up. The current is going to charge up. So that's going to be 10. V is equal to IR. So I is equal to V over R. So 10 over 2 And this is going to turn into what, 5? Yep, see, right over here. IL0 minus is equal to 10 over 2, 5 amps. So IL0 minus, we'll use burgundy. IL0 minus, whoops, that looks like a C. I'm going to constantly be doing that where my L's look like C's, just warning you. But just know that it's an L. So IL0 minus is equal to 10 divided by 2, which is equal to 5 amps. And just to let you guys know again, an inductor is just a wire, but it's turned, right? It just has a bunch of turns on it. So you don't include this L in the calculation. It's basically just, to calculate the current, it's basically just a voltage source and a resistor. So we found part 1. Now we have to find RL circuit for t is greater than 0. We're going to copy this equation up here. Okay, let's see if I could remember. DIL of t over dt. Okay, so we're going to do DIL of t over dt. As I said, my L's look like C's. Minus, or is it plus? I don't remember. I know it's like R over L. Plus RL ILT. And then this is equals to 1 over L V of t. Equal to 1 over L V of t. Okay. Now we just rewrite this with the R's and L's. The R was 2 ohms, I think, so D, yeah, I don't know. I think the R was 2, and I don't remember the L. I didn't even look at it. What's the L value? Resistor is 2, L is 2. Okay, so this is 2 over 2. This is a very easy problem. Plus IL of t is equal to 1/2 V of t. What was V of t? V of t is 10. Right? I think if you write 10, that should be correct. Oh no, I'm sorry. It's because of t is greater than 0. I always forget to do this. I always think it's the opposite one. This is for t is greater than 0. So this V of t is going to be 5. So this is 5 over 2. Five over 2, also known as 2.5. Right. Yeah, same for this capacitor one. We use 10 over here because that's the current source, and it's for t is greater than 0. Oh yeah, keep track of that as well. You're doing t is greater than 0. So we have that, and now we have to do the Laplace of this, right? And it's basically the same thing. This is almost the exact same thing as the capacitor one. So this is going to be S times I0t plus minus y0 minus, which is we found IL0 minus to be 5 amps. So this is going to be minus 5 plus I0t, sorry, not Z, I0t is equal to 2.5 over S. 2.5 over s. Right, so that should be that. Hopefully I'm doing this right. I'm gonna check back with the answer just to make sure I'm doing this right. But this is going to be s plus 1. I'll check back after I solve it. I0t minus 5 is equal to 2.5 over s, and then you have I0t is equal to 2.5 over s plus 5 divided by s plus 1, and as we know, luckily there's no s over here. Oh, we have to do this. Okay, so we have to do, I'm gonna have to solve this out in my head. So this is 5s, right? Wait, hold on. 2.5 over s. Yep. This is going to be 2.5 plus 5s over s divided by s plus 1. So keep, change, flip. This is going to be 2.5 plus 5s over s times s plus 1. All right, and we do the same thing over here. There's going to be a k1 and a k2. k1 over s plus k2 over s. And then you do the last step, which is part 3, I believe. V, or is it not V? It's I0t. Let me see what we write over here. I think it's, yeah, V0t. So this one's going to be I0t. I0t is equal to, I wrote s plus 1. K1 plus K2 equal to s plus 1. That turns into what, e to the t? I think that's it, right? E to the t. Positive 1. And we write it as an e value, not an s. E to the negative 2t. No. It's plus, so you invert it. Yeah. Okay. And I'm just going to hope that that's the answer over here. Let's check. K1 plus K2 e to the negative t. That's great, honestly. So this one isn't too bad, right? Especially part 1. Part 1 for this one and question 4 are like really easy to do. Or sorry, this is question 4. For this one and question 2, very easy to do. Always do those. I think the first part of everything, honestly, is very easy to do. This one's super easy to do. This one's super easy to do. This one's super easy to do. This one, not so much. Okay, fine. Problem 5 is not that easy to do. Find the representations xt. This one's easy to do. I think. Yeah. Yeah, because it's just asking for xt and ht. And then you convert it to hs to find y of t. So, there's a lot of parts on this final where you can get like a lot of points for this. You know, of course, I always just say do your best, do what you can. You know, also if you get stuck on a problem, just switch to a different problem, come back to it, and get as many parts done as you can. This is a very medium exam. I know it took me like a really long time to do this video, but it's not too bad. I just talk a lot and I have to explain, so you guys can definitely do this. I think the final exam is actually about like 2 hours to do, right? So for me to explain it in 2 hours, you guys could totally do this in an hour or so, whatever it is. But thank you for watching, guys. I really hope you do well for this exam. Um, if you guys have any questions, make sure to come on Wednesday. I'm going to have my last tutoring session on Wednesday at 12:30. Anybody is able to come. If you guys want to join, just go to the IEEE HKN Discord server if it can work. Um, and I will probably be in just tutoring one, right? Um, and you'll probably see me and like a couple of other people there. Um, and if you have any questions, just hop on, and I'll try to answer it to the best of my ability. But anyway, thank you for watching. Hope you do well on your exams, and I will see you next time. Also, have a good Christmas. Bye bye.